Hello, everyone. Welcome to Sleep Space. Tonight, we'll talk about something quietly profound: how your light is still out there, not just metaphorically, but literally. We'll explore the science behind how light, once it leaves you, keeps traveling across the universe. You'll learn why the photons that reflected off your face years ago are still moving outward into space, how light carries memory, and how distant galaxies offer us a glimpse into the deep past, just as you, too, are imprinted in the fabric of the cosmos. Before we begin, I'd love to know, where in the world are you listening from? And what time is it for you right now? Maybe it's just after sunset or deep into the quiet hours of the night. Wherever you are, know this: you are part of something vast and luminous. Let's explore it together. Light is one of the most fascinating entities in the universe. It travels at 192 kilometers per second, or about 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in 1 second. But more than just speed, light carries information. It reflects, refracts, bends, and transmits data about the world it touches. Every moment you spend in sunlight, under a lamp, or even walking through moonlight, photons are interacting with you. They bounce off your skin, your clothes, the whites of your eyes. When that happens, those photons don't just vanish, they continue their journey outward. They scatter in all directions, racing away from Earth at the speed of light. If nothing gets in their way, they could travel for billions of years. Now think about this. If someone had a telescope powerful enough and they were far enough away from Earth, they could look back in time. Just like when we observe distant galaxies, we're not seeing them as they are now, but as they were when their light first began traveling toward us. A galaxy that's a million light years away is showing us what it looked like a million years ago, because that's how long its light took to get here. The same principle applies in reverse. The light bouncing off you today is traveling outward, carving a path through the cosmos. If an alien civilization 100 light years away had the right technology, they might be watching Earth as it was a century ago. And if they had their lens focused just right, they might even see you, perhaps standing in a field, smiling into the sun, waving at someone you love. This isn't science fiction. It's grounded in the physics of light. Photons don't age, decay, or lose memory the way we do. Once emitted or reflected, they keep going until they interact with something that stops or absorbs them. Otherwise, they move forever. This is one reason astronomy is often called a form of cosmic archaeology. When we observe the stars, we are quite literally looking into the past. The Orion Nebula, for instance, is about 1,344 light years away. That means the light we're seeing from it tonight began its journey during the early 700s AD. Every twinkle is a time capsule. Now, imagine reversing that telescope. Imagine what it means for the photons that once danced on your face during a summer afternoon years ago. Those photons left Earth and are still racing outward, like messages in a bottle thrown into an endless ocean. The universe keeps them moving forward, carrying a memory of you imprinted in the light. There's something deeply comforting in this, because it suggests that nothing is ever truly lost, not in the way we often think. Even moments we can't remember are still out there in some form, etched in the wave fronts of light and encoded in the fabric of space-time. Let's get a little deeper into the science. When light reflects off a surface, it behaves like a stream of particles, photons that bounce off at predictable angles. Some are absorbed, depending on the surface's properties, but many escape. And once those photons are on their way, they're essentially untouched by time. They don't slow down, they don't decay. In the vacuum of space, they just go. This is one of the reasons why the cosmic microwave background, light from the very early universe, is still detectable today. That light has been travelling for nearly 14 billion years. It's faint, stretched into microwaves by the expansion of space itself, but it's still here. We can measure it. We can listen to the echo of creation. And if that's true for the birth of the universe, it's also true for you. Not on the same scale, of course, but the principle is the same. The photons from the light bulb in your childhood bedroom, the sunlight on your 6th birthday, the flashlight under your blanket while reading at night, all of those emitted and reflected photons in some form are still travelling. Now you might wonder, could someone actually find them? Could they somehow retrieve an image of you from light that has long since passed? In practice, no. The photons scatter too widely and the universe is far too noisy and vast. But in theory, yes. If you had perfect technology and could collect and reassemble every photon that left a given spot on Earth, you could reconstruct that moment, frame by frame, as it really happened. This is where physics meets poetry, because the idea that your light is still out there is not just wishful thinking, it's physically accurate. You have quite literally left a trail of light behind you in every moment of your life. You don't just exist in time, you extend into space. It's strange to think of yourself as a kind of beacon, radiating outward into the unknown, but that's exactly what you are. Every time light touches you and moves on, it carries something of you with it. A photon that reflected off your hand a decade ago may now be flying past a distant star. And that star may have planets, and those planets may have eyes looking back. In physics, there's a concept called the light cone. It's a way of visualizing the influence of an event through space-time. Imagine dropping a pebble into a still pond. The ripples spread outward in all directions. Now picture those ripples moving at the speed of light, radiating from every point in space where you've ever stood. That's your light cone, your expanding sphere of influence across the cosmos. The speed of light is more than just a number, it's a fundamental limit woven into the very structure of our universe. At approximately 186,000 miles per second, light is the fastest thing we know of. Nothing with mass can reach that speed, but photons, those massless packets of energy, travel it naturally. They are not bound by time the way we are. From their perspective, time does not pass at all. A photon emitted from a star billions of years ago doesn't experience the journey. It simply exists here and there, all at once. This strange quality of light makes it a kind of cosmic courier, carrying the past into the present. It's how we can see galaxies as they were billions of years ago, and it's how the light that once reflected off your skin continues racing into space, carrying a frozen imprint of a single moment in your life. Every second, trillions of photons are scattering off the Earth and heading outward. Most will never be intercepted. They will slip through the dark, unobserved, untouched. But they remain a silent record of what was. It's a natural archive, written not on paper, but on the waves of electromagnetic radiation, etched into the shape and frequency of light itself. Think of a single moment from your life, maybe the way sunlight streamed through the trees during a childhood walk, or how the flickering glow of candles reflected in someone's eyes. In those moments, light captured not only the scene, but you within it. Those photons moved on, perhaps caught in clouds or bouncing off walls, but many escaped, flying free from Earth, never to return. What makes this profound is that space is so vast and so empty that light, once free, can travel for unfathomable distances without colliding with anything. In that emptiness, it keeps its integrity, it keeps its angle, its frequency, its direction. It carries with it the signature of the object or person it last touched. And it just keeps going. It's easy to forget how much information light carries. When it bounces off something, it encodes data about color, texture, movement, and direction. That's how our eyes work. Photons hit the retina and trigger electrical signals interpreted by the brain as sight. Cameras operate similarly, capturing photons and freezing their data. But nature's camera is much more vast. It has no shutter. It never stops running. The universe is always watching. In theory, if you could freeze time and gather all the photons that left a specific room at a specific moment, you could reconstruct everything that happened there. Not just the shape of the room, but the expressions on people's faces, the way shadows moved, the way light scattered across surfaces. It's as though every instant emits its own film reel, and that reel continues outward forever. The concept is eerie and beautiful, because it means nothing is ever entirely gone. Light is an emissary of memory, a photograph taken by the universe, even if no one develops the film. This idea is mirrored in the way we look at the stars. Consider Betelgeuse, the bright red star in Orion's shoulder. It's about 642 light-years away. That means when you gaze at it on a winter night, you're seeing it as it was over 6 centuries ago, around the year 1383. It may already have exploded, but the light of that event hasn't reached us yet. The same is true for everything in the sky. When we look at the Andromeda galaxy, we're seeing light that's 2.5 million years old. We're seeing it not as it is, but as it was when early humans first started shaping tools. The stars are not just above us, they are behind us, echoing their ancient light across the gulf of time. That reflection goes both ways. If intelligent life exists in Andromeda, and they're looking toward us with unimaginable instruments, they might be watching a world that no longer exists. They might be seeing dinosaurs roam, or the first fires built by early humans. The Earth, from far enough away, becomes a historical broadcast, radiating its story one light second at a time. So what about you? What about the everyday, unnoticed moments? The laugh you shared on a sunny sidewalk, the tears that glistened in starlight, the time you stood in stillness, feeling wind pass through you like a breath from something ancient. All of those moments radiated photons. All of those photons are still moving. Somewhere, far beyond the planets, your light is part of the ongoing narrative of the universe. In classical physics, information can't be destroyed. This principle is still being debated at the quantum level. But for photons, the story is relatively clear. Once emitted, they continue to carry their message unless absorbed or scattered. That means each of us leaves behind not just physical traces, but radiant ones. A trail of light stretching outward like a comet's tail, endless and invisible. Astronomers even use this concept in reverse. The technique of light echo photography involves observing light from a stellar explosion as it bounces off interstellar dust. The original light burst has long passed, but its reflection allows scientists to reconstruct the original event from a different angle, almost like seeing the same moment from multiple timelines. Light, in this sense, gives us access to events we can no longer touch. That ability to read the past through scattered light is how we've come to understand the birth of stars, the collisions of galaxies, and even the formation of black holes. Light is not just illumination, it is record, witness, and carrier of time. And it isn't just visible light. Photons span a spectrum: radio, infrared, ultraviolet, X-rays, and gamma rays. Your body too emits light, not in the visible spectrum, but in the infrared. You're always radiating, always shining in wavelengths your eyes can't see. Sensitive instruments can detect this thermal signature. You glow more than you know. In the cold vastness of space, even this invisible light could travel. The warmth of your body, however faint, becomes part of the cosmic whisper. Every person is a light source, even in darkness. That might seem poetic, but it's also accurate. The laws of physics treat you no differently than a star or a galaxy. You radiate, you reflect, you emit. And once that light begins its journey, it doesn't look back. This is why light is so central to science. It's how we understand the universe. We can't visit distant galaxies, but we can study their light. We can't touch the early universe, but we can listen to its echo. Light is how the universe speaks to us. And whether you realize it or not, you've been speaking back the whole time. Every time you've stood in light, you've joined that exchange. You've reflected a part of yourself outward, your shape, your presence, your motion. Light carries that forward, on and on, into the unseen distances. To understand just how far your light can travel, we need to understand how vast space truly is. Distances in the universe are almost impossible to grasp in human terms. Our entire planet is just over 8,000 miles in diameter, yet the nearest star beyond the Sun, Proxima Centauri, is over 25 trillion miles away. That's more than 4 light years. It means that light from Earth takes over 4 years just to reach the very next star system. Now stretch that idea further. Your reflected light, those photons that once bounced off your skin or hair or fingertips, doesn't stop at the edge of our atmosphere. It slips through it into space and continues in all directions. A single second's worth of light travels about 186,000 miles outward. After an hour, your light is already over 670 million miles from Earth, past Jupiter's orbit. After a year, it's beyond the edge of the solar system, and unless it hits something, it keeps going. This isn't just abstract theory. The Voyager spacecraft, launched in 1977, are now billions of miles from Earth and still sending back faint signals of light, radio waves, which are also photons. That light takes over 20 hours just to reach us, but it proves the point. Light is tireless. It moves on with or without us. And because light behaves the same way across the cosmos, it gives us a kind of time map. When we look out into space, we're looking deeper into time. And the farther we look, the younger the universe appears. Galaxies further away look more primitive because we're seeing them as they were when the universe itself was younger. In a very real sense, telescopes are time machines, powered entirely by light. Now imagine turning that time machine around. Imagine if some civilization, billions of light years away, had a telescope powerful enough to isolate and reconstruct individual photons from Earth. It's a fantasy for now, far beyond our technological reach, but the physics allows it. If they were looking in exactly the right place at the right time and had unimaginable precision, they could see Earth as it was in the past. They might see dinosaurs roaming a lush, ancient landscape, or Ice Age mammoths moving across frozen plains. They might watch the first cities rise or ships cross oceans. And yes, they could see us. It's strange to think that your image, your shadow, your gestures, brief and unnoticed on Earth, might be flying through space, preserved in perfect clarity, headed toward a point of observation that doesn't yet exist. Light doesn't forget. It only moves forward. This has led some thinkers to wonder, is there a kind of immortality in light? If nothing is truly lost, if every reflection, every glint of sunlight off your eyes, every silhouette you've cast, still exists as traveling light, does that mean a version of you persists in the fabric of the cosmos? From a physics standpoint, this isn't about soul or consciousness, but it is about information. And in modern physics, information is as fundamental as matter and energy. It's something the universe keeps track of. It may be scattered, it may be nearly impossible to recover, but it's never completely destroyed. The light that leaves you carries information about who you were in that moment, your location, your shape, your movement. That information continues to travel, independent of your awareness. This is why black holes became such a scientific mystery. For a long time, physicists believed that when matter fell into a black hole, its information was destroyed. But this idea conflicted with one of the most basic principles of quantum mechanics, that information must be conserved. The solution, proposed by Stephen Hawking and others, is that black holes might actually preserve information on their surface, the event horizon, encoded in subtle patterns we don't yet understand. If that's true, even in the most extreme conditions in the universe, it suggests a deep truth, that the universe is always recording, always remembering, not with emotion or intention, but with precision, through physics, through light. There's another way to think about this. Picture the Earth from space. It's glowing, not just in sunlight, but in all kinds of light. Radio, infrared, ultraviolet, and more. Cities twinkle at night. Storms flash with lightning. The auroras shimmer near the poles. And every second, the Earth is emitting photons in every direction. Some of those photons were reflected off you. From space, you are part of that glow. Not metaphorically, literally. You are one of the countless sources of light on this planet, however small. A single firefly barely registers from afar, but with a sensitive enough detector, it can be seen. The same is true for you. Your light joins the Earth's, radiating outward in a continuous shell, expanding every second. That shell of light becomes a kind of record, a boundary between what is visible and what is still hidden, a wavefront of memory. Inside that sphere is Earth's past. Outside, it is the future that has yet to witness what you've already done. The further that light travels, the more spread out it becomes. It weakens, it thins, it becomes harder to detect, but it doesn't vanish. If a photon from a moment 10 years ago is still flying outward through space, it's still there. You are, in a very real sense, still unfolding across the galaxy. Now let's zoom in again. Back to you. Back to this moment. If you're sitting in a quiet room right now, light is bouncing off everything around you. It's touching your face, your surroundings, the fabric of your clothes. That light is leaving this room right now, forever. If there's a window nearby, some of it escapes into the sky. If the walls absorb it, it becomes heat. But much of it escapes into the night, into the atmosphere, into space. Most of it won't be noticed, but some of it might someday be caught by instruments, by accident, by curiosity. And even if it's never observed, it still travels. The universe doesn't require an observer for light to move forward. Light simply goes. This realization reshapes the way we think about existence. We often imagine our lives as fleeting, moments passing, never to return. But light tells a different story. It says that every moment radiates, that nothing is ever completely gone, that the universe contains a continuous imprint of everything that ever was. One of the most astonishing truths about light is that it doesn't experience time. According to Einstein's theory of relativity, time slows down for objects moving close to the speed of light. But for light itself, traveling at that ultimate speed, time effectively stands still. From the perspective of a photon, the moment it is emitted and the moment it is absorbed happen simultaneously. That means a photon leaving your hand, reflecting off your skin and into space, experiences no time between its point of departure and wherever it ends up, even if that's billions of light years away. In the photon's experience, it simply travels from here to there, without aging, without delay. In a way, it freezes the moment of its birth forever. This is part of why light is such a powerful preserver of the past. It's not just that it travels, it's that it preserves a moment exactly as it was, indefinitely. If we could collect the right photons, we could reconstruct the past with perfect clarity. That isn't just poetic, it's the foundation of observational astronomy. When we look at ancient galaxies, we're not seeing representations of the past, we're seeing the past itself, delivered by light that left those galaxies billions of years ago and has only just reached our eyes. This ability to look backward is built into the fabric of space-time itself. Because light takes time to travel, every moment becomes a visible echo for someone, somewhere. The entire universe is full of these echoes, overlapping layers of light, constantly moving, constantly preserving. It also means there is a version of Earth visible at every distance, depending on how far away the observer is. A planet 1 light year away would see Earth as it was 1 year ago. A planet 1,000 light years away would see the Earth of the medieval era. And planets millions of light years away would see a world with no cities, no languages, no humans at all. What they would never see, at least not yet, is today's version of Earth, because the light from this moment hasn't reached them. We are always revealing our history, one photon at a time, to the cosmos. Your place in this is quiet but profound. You're not just witnessing the light of others, you are also part of the broadcast. You are constantly emitting and reflecting light into this invisible, expanding record of existence. Even when you're still, even when you're unaware, your body and your environment are shaping the light that leaves this planet. In that sense, the universe is a kind of mirror, not one that shows your reflection in the moment, but one that reflects your presence outward in time. Your image doesn't vanish, it simply moves away. The further it goes, the older it becomes. But it's still there, encoded in the traveling waves of electromagnetic radiation. Consider this. The average person spends a lifetime under various kinds of light: sunlight, artificial light, firelight, moonlight. With every passing second, trillions of photons are bouncing off your skin, your hair, the whites of your eyes. The photons that are not absorbed continue moving forward, carrying information about your posture, your expression, your presence. They are indifferent to meaning, but they are precise. They record what they touch. That doesn't mean someone will find them. Most of these photons will scatter into deep space, intercepted by dust, lost in starlight, or diluted beyond recovery. But their journey is real. You create ripples in the electromagnetic sea just by being here. and those ripples travel farther than anything else you will ever create. Even light trapped by walls, absorbed by surfaces, or caught in clouds doesn't disappear completely. When absorbed, it's transformed into heat, another form of energy. That heat might warm the air, trigger a chemical reaction, or radiate again in infrared light. In physics, energy never vanishes. It only changes form. Your presence moves through the world in these transformations, visible and invisible, direct and indirect. The light from a star can pass through space for billions of years and still have enough energy to be detected by a telescope on Earth. And in principle, the same is true of the light that once touched you. Its reach is not limited by your awareness or intention. The light doesn't ask to be remembered. It simply moves forward. This is why scientists say that the sky is not dark. It's only dark to our eyes. In truth, space is filled with light. Most of it is invisible, stretched into infrared or radio waves by the expansion of the universe. But it's there, woven into every corner of the cosmos. A faint glow from the past, always expanding, always unfolding. You are part of that glow. Your light joins the chorus of the universe, and while it may be quiet, it is not lost. The photons that once bounced off your laughter, your movement, your stillness, those photons are still moving, still traveling, still describing a version of you that existed and still exists in the record of light. It also reframes how we think about photographs and memory. A photograph is simply an artificial way of catching light. We freeze a moment by capturing the photons that bounced off a person or a place and preserving them on film or in digital code. But the universe doesn't need cameras. It records continuously, not with intention, but with motion. Light doesn't stop to archive. It becomes the archive. And because the universe is always expanding, the light you emit doesn't just stay nearby. It moves outward through space that itself is stretching. That means your light travels further than it would in a static universe. Space-time itself helps carry your image outward, farther than it could go otherwise. So what happens to this light as it spreads out? As it moves away from Earth, it thins. The further a wave travels, the more it disperses. It becomes weaker, harder to detect. But that doesn't mean it disappears. It just becomes subtle. Like a whisper traveling across a canyon, it's still there, just harder to hear. The universe is filled with these whispers, light from ancient stars, light from unknown galaxies, light from ordinary lives on an ordinary planet. It all moves together, overlapping and interweaving, and your light is among it. You might think of yourself as small, as fleeting, as temporary, but from the perspective of light, you are luminous. Your image moves outward in all directions, creating an expanding sphere of influence. Even if no one ever sees it, that light was still real. That moment still happened. That impression still exists. This is not mysticism, it's physics. It's what happens when photons reflect and escape into the vacuum of space. It's what happens when a star burns, or a hand waves, or a face turns toward the sky. The light leaves and carries the truth of that moment, unchanged by time, unburdened by memory. The idea that your light continues outward long after the moment has passed invites us to consider something deeper, the nature of time itself. We experience time as a forward-moving arrow, past, present, future, always changing, always leaving things behind. But in physics, particularly in the realm of relativity, time is not quite so linear. It's part of the fabric of space-time, woven together with space into a single, four-dimensional continuum. In this model, every moment that has ever existed still exists, just not all in the same location. The past hasn't disappeared, it has simply moved out of reach, and light is the bridge between those unreachable places. It connects us to other times, other conditions, other realities. Your light, those photons that once reflected off your body, your face, your gestures, is a link between the moment it left and the infinite stretch of time that follows. It may seem like a small thing, a technicality of physics, but in truth, it changes everything, because it means that no moment is truly lost. No presence is ever erased. Once light has carried it forward, it remains etched into the unfolding of the universe. Let's look again at the concept of the light cone. Imagine an event, say, you standing in a field on a sunny day. At that moment, photons begin radiating outward in all directions. As they spread through space, they form a kind of cone-shaped region in space-time. Everything inside that cone is reachable by the light from that event. Everything outside is not. That cone continues to widen indefinitely. 100 years from now, your light cone will have reached stars dozens of light years away. In 1,000 years, it will encompass entire star clusters. And as long as the universe exists, the sphere created by your light will keep growing. This means that the moment of your presence continues to ripple outward forever. Not metaphorically, but literally. Not as memory, but as physics. You leave a permanent mark on the cosmos, one photon at a time. Now let's imagine something more speculative. What if advanced civilizations do exist, far more advanced than us? And what if they have mastered techniques for observing faint light across enormous distances? In theory, they could look back and see Earth not as it is now, but as it once was. They might observe the formation of oceans, the rise of cities, or even single people, moving, living, unaware that their image is being observed from light years away. While we don't currently have the means to do this ourselves, it opens the door to a strange possibility. The past is not truly gone. It's just elsewhere. It's being carried by light that has moved beyond our reach, but not beyond all reach. Somewhere, in the vast stillness of space, your light still travels. And it's not just visible light. As mentioned before, humans emit infrared radiation due to body heat. We also emit faint electromagnetic waves through movement, through electrical impulses in our bodies, and through sound vibrations transferred into the air and, in some cases, the Earth. While these forms of energy don't travel as efficiently through space as light, they're part of the overall energetic imprint you leave on the world. In the realm of astronomy, scientists have used this principle to study everything from ancient galaxies to supernova explosions. Light echoes, as they're called, allow astronomers to witness cosmic events long after they've occurred, by observing the light that has bounced off surrounding material and only now reached our instruments. It's a cosmic reflection, a delayed replay of events written in scattered photons. In much the same way, your own existence creates echoes, not just in memory or in people's hearts, but in the physics of the world around you. You send out waves. Light touches you and continues on. It brushes against surfaces you never noticed, enters the sky without asking, and travels into the deep night, carrying a silent message. You were here. It's humbling to think about, but also quietly empowering, because it means that even the smallest moment is preserved, not in a way we can always retrieve, but in a way that is real. a glance at this, a breath, the way you looked out a window at dusk. Those moments are part of an ever-expanding field of light, leaving Earth and never coming back. So what does this mean for who we are? It suggests that our presence has more permanence than we realize. We often measure life in terms of memory or achievement or impact, but there is another, quieter measure: how we changed the light, how we interacted with the flow of photons moving through the world. Every touch of light on your skin is a recorded event. Every time you moved through sunlight, or under streetlights, or beside a flickering candle, you left an imprint. It also invites us to consider what we're made of, not just biologically, but energetically. The human body is a dynamic system of motion and interaction. At the atomic level, we are mostly space. The particles that make up our bodies are in constant motion, exchanging energy with their surroundings. And much of that energy is electromagnetic. In other words, light. To understand just how far your light can travel, we need to consider the true scale of the universe. Light moves at 299,792 kilometers per second. That's fast enough to circle Earth more than 7 times in a single second. In just 1 year, a single photon can travel about 9.5 trillion kilometers. That's what we call a light year. And in the vastness of space, light years are the only units that even begin to make sense. So when we say that the light that reflected off you continues outward, we're talking about something that stretches into staggering distances. After 10 years, it has traveled 10 light years. After 100 years, it's 100 light years from Earth. That might not sound like much compared to the size of the observable universe, which is over 90 billion light years across. But let's put it in perspective. There are dozens of stars within just 10 light years of Earth. 100 light years encompasses hundreds more. In 1,000 light years, you've already reached regions that contain tens of thousands of stars, each potentially surrounded by planets, moons, and dust clouds. Your light, once faint and local, now belongs to the larger galactic rhythm. It becomes part of the background of the Milky Way, part of the ocean of starlight that fills the night sky. And it doesn't stop there, because space, while incredibly vast, offers very little resistance to photons. Once a photon escapes Earth's atmosphere, it is not slowed down. It is not absorbed unless it hits something. Most of the time, it just keeps going. It will travel forever unless it collides with a planet, star, or piece of interstellar dust. That means the light from your body, your presence, isn't just drifting. It's racing across the galaxy at full speed. Now let's take a moment to think about how we observe the cosmos. When we look at a galaxy that's 100 million light years away, we are seeing it not as it is now, but as it was 100 million years ago. The light left that galaxy when dinosaurs still walked the Earth. In fact, most of the universe is being seen through this kind of time delay. We never see anything in real time. Every image of the stars is a glimpse into the past. This same principle applies to you. If there were an unimaginably distant observer, 1 trillion kilometers away with a telescope precise enough to pick out the details of Earth, they would see Earth as it was in the past. And if their timing were right, they could see you. They could witness a moment in your life long after you've forgotten it. They would see you not as a memory, but as light, a real-time snapshot delayed only by the distance it traveled. It's worth emphasizing that this isn't just a poetic thought. It's grounded in the same physics that allows astronomers to study the early universe. The same principles that let us measure the light from the cosmic microwave background, the afterglow of the Big Bang, allow us to imagine our own light traveling forward in time and outward in space. Your life, from the perspective of physics, is a luminous event. Each moment sends photons into space. Every second of your existence contributes to the ongoing radiance of Earth. If Earth were viewed from far enough away, it would sparkle, not just from oceans and clouds and sunlight, but from the trillions of tiny reflections cast by every living being, every movement, every breath. You are part of that sparkle. Your light is woven into it. And even though we humans are made of dense, complex matter, flesh, bone, water, we are still porous to light. Every time you walk through sunlight, light bounces off your skin, your clothes, your hair. It's not just illumination, it's transfer. Information about you is imprinted on that light and carried away. Not as full-color images, of course, but as subtle distortions, patterns, and intensities that encode your presence at that exact time. It's hard to imagine because we don't see it happening, but sensitive cameras can capture it. Even now, high-resolution imaging can reconstruct 3D maps of rooms based only on light reflected off walls. If our technology continues to advance, it's possible we'll one day recover even finer details from reflected light in the environment. And if that's true locally, on Earth, then what might be possible at cosmic scales? Could ancient civilizations reconstruct the early history of planets by analyzing the light that left them long ago? Could they observe our species, our cultures, our histories as light passing through the cosmos? This might sound like science fiction, but it's rooted in the same physics that lets us see supernovae from across the universe. It's the same idea that lets us study the atmospheres of exoplanets by examining the light passing through them. Information is always there, carried by photons. It's just a matter of what you can extract from it. And again, this isn't limited to visible light. The electromagnetic spectrum spans a vast range, from gamma rays to X-rays, ultraviolet to infrared, microwaves to radio waves. Each part of the spectrum interacts with matter in different ways, and each carries its own kind of information. Humans emit infrared due to body heat. We generate low-level electromagnetic fields. We disturb the air with vibrations. All of this becomes part of the broader signature of life on Earth. It's as if Earth itself has a voice, a radiance, a kind of whisper in every direction. Not loud, not obvious, but steady, persistent. And within that whisper are your own frequencies, your own reflections, your own trace. So when you wonder whether a moment has passed completely, whether something you experienced is truly gone, remember that, from the perspective of the universe, nothing disappears so easily. Not when it has traveled in light, not when it has left Earth and begun a journey that could last billions of years. Every photon that ever bounced off your skin and escaped into space is still moving, still flying outward, still expanding the record of your existence. And there is no known mechanism in physics that brings those photons back. Once released, they are on a one-way path across the universe, a luminous breadcrumb trail left behind by your presence. This opens up profound philosophical questions. If your past moments are still out there, still traveling, what does that mean about your place in the cosmos? If your light continues indefinitely, are you not in some way eternal? Not in a conscious, ongoing way, but in a structural, physical sense. You are part of the visible history of the universe, part of the stream of light that defines what can be seen, what can be known. If we imagine your light continuing to travel outward, the next question becomes, what does it encounter along the way? At first, your photons pass through Earth's atmosphere, scattering slightly as they do, especially in the case of shorter blue wavelengths. Some are absorbed by molecules in the air, but many continue on, especially the longer red and infrared wavelengths, which pass more cleanly through atmospheric layers. Once beyond that boundary, your light enters what's known as cislunar space, the region between Earth and the Moon. From there, it continues through interplanetary space, past Mars, through the asteroid belt, and beyond the orbit of Jupiter. Every few years, depending on the direction and timing, your light could pass by a planet in our solar system. Some photons might be absorbed by dust or intercepted by spacecraft, but most go undisturbed. The emptiness of space, while not absolute, is vast. Even in the regions crowded with asteroids or Kuiper belt objects, the average distance between particles is enormous. This means that the overwhelming majority of photons travel billions of kilometers without ever hitting anything. They just continue, past Pluto, past the heliopause, the boundary where the solar wind from the sun gives way to the interstellar medium. That crossing is symbolic. It marks the edge of our solar system. Once your light passes through that invisible threshold, it enters the galaxy proper. Now it begins its journey among the stars. The Milky Way is a spiral galaxy, about 100,000 light-years across, with roughly 200 to 400 billion stars. These stars are not evenly spaced, but instead grouped into arms, clusters, clouds, and voids. Your photons might pass through regions rich in starlight, then drift into dark corridors filled with cold gas and dust. They might be tugged slightly by gravity as they pass near massive bodies, a phenomenon known as gravitational lensing. In this way, the path of your light can curve, bend, and refract as it travels, even though nothing touches it directly. This bending of light is more than just a theoretical idea. It's the same principle used by astronomers to detect dark matter, observe distant galaxies, and map the large-scale structure of the cosmos. Light doesn't need to be absorbed or reflected to be affected. It responds to the shape of space-time itself. So when we say that your light is still out there, we are acknowledging not just its presence, but its journey. It's navigating a dynamic universe, one shaped by gravity, motion, and the invisible scaffolding of cosmic evolution. Your photons aren't drifting lazily. They're flying through a structured environment shaped by galactic tides and deep time. Occasionally, one of your photons may encounter an interstellar dust grain. These are tiny, microscopic particles made of carbon, silicon, and oxygen compounds scattered throughout the galaxy. If a photon strikes one of these, it might be absorbed and converted into heat, or it might scatter in a new direction. But again, the odds of this happening are low. For the most part, your light travels undisturbed. Incredibly, some of your photons may even make it to other star systems. If timed perfectly, they could pass by alien worlds. Worlds with oceans, clouds, atmospheres. Perhaps even life. What would those photons carry with them? Information, not in the form of images or voices, but in wavelength, angle, polarization, and interference patterns. Subtle fingerprints of the moment they were born. Traces of Earth, traces of you. Could another civilization detect that light? In theory, yes. If they had a telescope advanced enough, sensitive enough, and if they knew where to look. They could detect the gentle glint of a photon that left Earth long ago. They could run it through filters and measurements, and perhaps extract some trace pattern from it, though it would be exceedingly difficult. Still, in a universe of infinite possibility, difficulty does not mean impossibility, and even if no one ever intercepts it, that doesn't erase its journey. Because in physics, the path of a photon is real. It carries energy, momentum, and in some interpretations of quantum mechanics, it also carries a record of its interactions. Once emitted, it becomes part of the cosmic web, another thread in the tapestry of light that weaves across galaxies. It's hard to grasp how much light exists in the universe. The observable cosmos contains over 1 trillion galaxies. Each one beams with the radiance of billions of stars, planets, and other luminous bodies. But even amid all that brightness, each individual photon matters. There's no such thing as too small to count. In the mathematics of light, every contribution shifts the field, even if only by a minuscule degree. And your contribution is not theoretical. It happened. Every second, trillions of photons reflect off your body and launch into space. Some from your skin, others from your hair, your clothes, your eyes. Some from the heat of your body itself. And each of them begins a journey that, absent an obstacle, can go on forever. Let's pause for a moment to reflect on the philosophical implications of this. We often think of ourselves as tiny, ephemeral, fleeting moments in a giant, indifferent universe. And in some ways, that's true. Our lives are short compared to cosmic timescales. Our bodies occupy no more than a few meters of space. But our radiance, our light, that is unbounded. We are beings who shine, not metaphorically, but physically. We are radiant creatures embedded in a radiant cosmos. And while that light may be invisible to the naked eye, it is no less real. It is no less eternal. Some philosophers and physicists have speculated that in a far future, civilizations might reconstruct the past by collecting ancient photons, a sort of cosmic archaeology, not digging in the ground, but sampling the light that has wandered across the eons. While this remains speculative, it is not impossible. Every interaction leaves a mark. Every emission carries a story. Every photon tells us something, even if we haven't yet learned how to listen. So where is your light now? If you're in your 30s, the light from your childhood has already traveled over 30 light years. It has passed hundreds of stars and planetary systems. It may be shining through nebulae or bouncing gently off dust particles in the interstellar medium. If you're older, even more of your past light is scattered across a larger region, an expanding shell of photons surrounding Earth like a luminous echo. Let's imagine that light as a bubble. A luminous shell expanding outward at the speed of light, 300,000 kilometers per second. It grows with every passing moment, rippling through the fabric of space like a message that never ends. In this metaphorical bubble, each layer corresponds to a different moment in time. The innermost layer might contain photons from your most recent breath. Just outside that, the light from the words you spoke an hour ago. Further out, the radiance of yesterday's laughter. And farther still, the soft glow of a memory from childhood, now racing across interstellar space. If you were to freeze the universe in this instant and trace every photon back to its origin, you would find a three-dimensional sphere around Earth, layered with the events of your life. This is not a metaphorical memory, it is an actual structure in space, one that expands, evolves, and, for the most part, goes on undisturbed. Photons, unlike matter, don't age in the traditional sense. Because they travel at the speed of light, they experience no passage of time. In their own frame of reference, they are emitted and absorbed instantly, regardless of the distance between those events. So a photon from your first steps could, in theory, be absorbed by the eye of an alien 100 light years away. And from its perspective, that moment would just be beginning. What a strange and beautiful thought, that a sliver of your life might only now be arriving at its destination, completely unchanged by time. A particle of light carrying your presence, your shape, your signature, intact across the centuries. Now imagine the entirety of what's Earth from this perspective. Every moment in human history, every light that has ever been cast, is still travelling outward in overlapping waves. The light from the pyramids being built, the glow of ancient fires, the shimmer of medieval candles, the electric dazzle of city lights in the 20th century. They all ripple through space in expanding shells, intersecting with starlight, passing planets, and brushing the edges of cosmic clouds. Our planet is not just spinning in space, it is radiating into it. And while we often think of history as being confined to the ground, the ruins, the bones, the books, it also exists up there, in the photons that escaped. The light is the history, and in that sense, you too are part of cosmic history, not in the metaphorical or symbolic way, but in the measurable, physical one. You might wonder, if this light is so real, why can't we see it? Why doesn't the night sky shimmer with echoes of ourselves? The answer lies in the nature of detection. Space is vast and light disperses. Photons spread out over incredible distances. By the time a single photon from your reflection reaches another star system, it may be diluted among billions of others. Its signal is weak, not gone, just difficult to isolate. Like a single drop in the ocean, it is still there, but hard to find. However, this doesn't make it any less real. The laws of physics don't depend on what we can currently detect. They operate with quiet precision, regardless of our tools or understanding. So the sky isn't silent, it's just subtle. It's filled with the light of things we've forgotten. Events long past, glances, gestures, dances, and days. And while no one may be watching, the universe holds them nonetheless. Not as conscious memories, but as waves of probability, fields of influence, and paths of energy. Now let's go further. Beyond the stars your photons may pass are entire galaxies, each a swirling city of light. Some are close neighbours, like the Andromeda galaxy, which your light could reach in about 2.5 million years. Others are unimaginably distant, scattered across the observable universe. The light you've emitted will continue to travel toward them, unless it is blocked, bent, or absorbed. And here's something remarkable. In the farthest reaches of cosmic time, even if Earth were to vanish, even if memory were lost, your light would remain, not as a symbol, but as a physical fact. Somewhere, somehow, the photons from your presence would still be in motion, echoes of your being embedded in the trajectory of the cosmos. This brings us to a profound realization. In a universe governed by light, nothing is ever truly lost. It is transformed, redirected, reshaped, but not erased. That's the beauty of photons. Once they leave, they belong to space itself. They aren't bound by your body or your identity or even your timeline. They're free, and in that freedom, they become universal. You are not confined to the here and now. Your influence, literal and luminous, extends across time and space. Even if no one remembers the moment, the light from it still exists. Your smile, your movement, your spark. It's all out there, still traveling, still touching the edges of infinity. And now, as we rest in this idea, you can feel the vastness around you, not as something to be afraid of, but as something you are part of. You belong to this universe not only by being in it, but by radiating into it. You are a source, a point of origin, a presence that persists in waves and particles, light and vibration. As Carl Sagan once said, we are a way for the cosmos to know itself, but perhaps we are also a way for the cosmos to reflect itself. Your light is a mirror, catching a glimpse of the infinite and sending it back outward. Each breath you've taken, each laugh you've shared, each time you've looked toward the stars, they looked back, not metaphorically, but physically, because your gaze reflected light, because your body radiated warmth, because your presence stirred the photons. As your light continues its vast journey, it's important to consider one more remarkable aspect of how photons travel through the universe: the influence of cosmic expansion. Our universe isn't static, it's stretching. Space itself is expanding, causing galaxies to move farther apart over time. This expansion affects the light traveling between them in a process known as redshift. Essentially, as space stretches, the wavelength of light also stretches, shifting toward the red end of the spectrum and lowering its energy. What does this mean for your light? The photons that once reflected off you are not only moving outward, they're also being stretched. Their wavelength grows longer as they travel through expanding space, becoming less energetic and shifting into infrared or even radio frequencies after enough time. This transformation changes how that light would appear if it were ever observed from afar. Yet, this redshift doesn't erase the information carried by the photons. Though the energy diminishes, the light still encodes the history of the moment it left Earth. The patterns, the angles, the polarization all remain, only altered by cosmic expansion. This cosmic stretching extends the journey of your light across epochs and galaxies, enabling it to weave through the cosmic web, a vast network of galaxies and dark matter filaments that structure the universe on its largest scales. Even though your light weakens and changes color as it travels, it remains an active participant in the universe's story. It becomes part of the diffuse background glow known as the cosmic microwave background's foreground, a gentle glow that carries the echoes of all the light ever emitted. Now, while the idea of your light endlessly traveling through space is awe-inspiring, it's worth noting that the probability of any individual photon from your body being intercepted or observed by an alien civilization is extraordinarily low. The universe is unimaginably vast, and light disperses over ever-growing spheres. But improbability is not impossibility, and in a cosmos as vast and old as ours, every photon that escapes carries a faint chance of being discovered. Perhaps someday a civilization will develop technology sensitive enough to pick out these ancient photons. Perhaps they'll reconstruct snapshots of Earth's past. Perhaps in those photons they'll find a trace of you. As we come to the close of this cosmic journey, it's time to bring your awareness gently back to the present moment and to the restful state that awaits you. Tonight, as you listen in whatever place and time you find yourself, remember that your light, your very presence, has been traveling outward through space for years, decades, even centuries. Every photon reflected, every glimmer of your being cast into the universe is still out there, not lost, not gone, but journeying forward through the vastness. This thought carries a quiet comfort. It connects you to the stars, to the galaxies, to the endless fabric of space and time. It reminds us that while our bodies rest and our minds drift into sleep, our essence, encoded in light, reaches far beyond. Sleep is a time of renewal, a time when your body restores itself and your consciousness lets go of the day's events. It is also a time when you can feel connected to yourself, to the universe, to the deep stillness of existence. As your body grows heavier and your breath deepens, imagine yourself as part of this luminous flow, a small but radiant point sending light outward, joining the endless chorus of the cosmos. Your light mingles with starlight, with ancient photons, with the silent music of space. You are not alone. You are not fleeting. You are part of a story written in the language of light, unfolding over infinite distances and infinite time.
Let this knowledge ease your mind. Let it carry you softly into rest.
The photons that once reflected off your face and hands continue their journey, quiet travelers through space, just as your thoughts now drift toward sleep. Close your eyes if you wish. Feel the calm that comes with knowing you are connected beyond the here and now. Let the gentle rhythm of your breath align with the steady pulse of the universe.
Your light is still out there, and you are safe, held in the quiet embrace of the cosmos.
Sleep well.